Hello students, in this lecture also I'll be discussing about piezoelectric crystal. We'll see the equivalent circuit of piezoelectric crystal, then we'll see the equivalent network of piezoelectric crystal when a piezoelectric transducer, when a cable and amplifier is applied in that network. So let's start. So as I've told you, in piezoelectric crystal, like any transducer, they can be represented in terms of voltage source or current source. Why? Because the transducer, what is the work or what is the operation of what is the work of transducer? It converts any physical quantity into electrical quantity, that is voltage or current. So any transducer can be represented in terms of voltage or current source, but here we have represented piezoelectric crystal or piezoelectric transducer in terms of current source. And as I've told you, this piezoelectric transducer is used for measuring dynamic force or dynamic stress or dynamic pressure, means the force that is varying with time, and it gives the output charge. So what is happen, if you apply force, then charge will get generated across the surface of the crystal of piezoelectric. But if you apply dF by dt, that is dynamic force, obviously you will get dq by dt. For one force you will get one charge, for another force you will get another charge. So in this way, if the force is varying with time, you will get output dq by dt. So piezoelectric crystal, if you apply dynamic force, you will get dq by dt as output. Now piezoelectric crystal has internal leakage resistance. As I have told you, piezoelectric crystal works as a capacitor. It will have capacitance value Cp, as well as it will have internal leakage resistance, which is Rp, and this Q is denoting the charge, or you can say this is the current source. This whole is the current source. In current source, what happens? The resistance and all, they are connected in parallel with this current source. So similarly, the internal resistance and capacitance of piezoelectric crystal is connected in parallel with this current source. So this whole is the equivalent circuit of this piezoelectric crystal. This is the charge that gets generated or the current that comes out of the piezoelectric crystal. Now we know current is equal to I is equal to dq by dt, where the charge Q in piezoelectric crystal, it is equal to dF, as I've already explained in my previous lecture, that Q is equal to dF. So we will be writing Q is equal to dF in this equation, d by dt in bracket dF, that is Q is equal to dF. Now this d, which is the charge sensitivity, it is a constant value, where the force that is applied to the piezoelectric crystal, it is a dynamic force, that is time varying force. So the constant will be out and d by dt of F will be there only. So this I, that is the current that is coming out of this piezoelectric crystal, is equal to d into d by dt of this force, or dF by dt. Now the charge so generated, or the voltage so generated across this piezoelectric crystal, is very small. We need an amplifier to amplify this. So we'll be using a cable and then an amplifier to this network. And the equivalent circuit of this network here, this is the piezoelectric crystal, that is the current source, and in parallel Rp and Cp, that is the internal resistance and internal capacitance of piezoelectric crystal, like this equivalent circuit I've drawn here. And the cable will also have the resistance and capacitance, and the amplifier is also having the resistance and capacitance. So this is the equivalent network of this. Now this whole network can be simplified, like all the resistances, we can find the equivalent resistance value, that is these resistances are connected in parallel, as well as the capacitance are also connected in parallel. We can find the equivalent resistance and equivalent capacitance, and we can simplify the network like this, where R equivalent is Rp parallel, that is what is Rp? That is the internal resistance of piezoelectric crystal, parallel to the resistance of cable, parallel to the resistance of amplifier. As you can see, Rp parallel RCA parallel R amplifier. In the same way, C equivalent is equal to Cp parallel, that is internal capacitance of piezoelectric crystal, parallel to cable capacitance parallel to amplifier capacitance. So as we know, when the capacitances are connected in parallel, they get add up, that is Cp plus Ca plus Cm. So Ca plus Cm we have represented it by C load. So all total we can write Cp plus C load. So when resistances they are connected in parallel, the equivalent resistance value gets reduced, whereas when the capacitances are connected in parallel and when the capacitances are in parallel, they get add up and the equivalent capacitance value gets high. And because of this high value of capacitance, there is loading effect. So this is the internal capacitance of piezoelectric crystal and this is the loading effect of the capacitance, and because of this the whole capacitance value gets high. Tau is the time constant which is equal to RC, or you can say R equivalent C equivalent. Now we'll find the frequency response of this piezoelectric network, that is the network consisting of piezoelectric crystal, cable and amplifier. This is the equivalent simplified network having I, R equivalent, C equivalent. Now from this network you can see I is equal to I1 plus I2. It is getting divided into two currents. So I is equal to I1 plus I2. What is I1? I1 is equal to E divided by R equivalent. So here I have written E divided by R equivalent. And what is I2? It is the current through the capacitor, which can be written as C dE by dt. And what is I have already written here that I is equal to D into dF by dt. So it's the same thing I have written here, D into dF by dt. Now here I have written K in place of D. Anything you can write. This is all representation only. So whenever in the remaining of this derivation I have used the value K, but K is meaning D only, that is the charge sensitivity. So K and D both means the same thing and they are replaceable. This is charge sensitivity. Just I have replaced the symbol D by K. Now this is K dF by dt is equal to, now what we will do, we'll take R equivalent common. So R equivalent we have taken common, it will be E plus R equivalent into C equivalent dE by dt. Now we'll take R equivalent to this side and we'll get R equivalent into K dF by dt is equal to E plus, now R equivalent into C equivalent is tau equivalent, that is time constant, into dE by dt. Now we'll divide and multiply by C equivalent to this side. So here we have done 1 by C equivalent into C equivalent and the whole thing will remain same. So R equivalent into C equivalent will represent it by tau equivalent, and then it is equal to tau equivalent into 1 upon C equivalent into K dF by dt is equal to E plus tau equivalent dE by dt. Now K divided by C equivalent will represent it by K dash. We will represent this term by K dash. So tau equivalent into K dash into dF by dt is equal to E plus tau equivalent dE by dt. Now this K dash, as I have told you, we have what is K dash? K dash is this K divided by C equivalent. So this K divided by C equivalent, it is, you just remember this term, I'll tell you what it is. It is the sensitivity of overall network. This K dash is the sensitivity of overall network. Now moving ahead with the derivation, tau equivalent into K dash into dF by dt is equal to E plus tau equivalent into dE by dt. Now we'll apply Laplace transform because we need to find the transfer function of this piezoelectric network. So applying Laplace transform, what it would be, it is equal to tau equivalent into K dash into S into Fs is equal to E plus tau equivalent into SES. Now we'll take ES by Fs, which will come out to be tau equivalent into K dash into S divided by 1 plus tau equivalent into S. So this is the transfer function of the piezoelectric network, the network which is having piezoelectric crystal, the cable and the amplifier. So this is the transfer function of the piezoelectric network. Now I told you that K dash is equal to K divided by C equivalent in my previous slide, and this is what is C equivalent? C equivalent is Cp plus C load, as I've told you here also. What is C equivalent? C equivalent is equal to Cp plus C load. So I've written it here also. C equivalent is Cp plus C load. And what is the unit of this K? Unit of K is volt per Newton. So this K dash, or you can say if you are representing it with D, then this D dash is the sensitivity of overall piezoelectric network. K, or you can say D, is the charge sensitivity of crystal, as I've already told you in my previous slides, and G is the voltage sensitivity of crystal. So basically the true value of the piezoelectric network that should come out is this G. This is the voltage sensitivity, that is the true value. But what we get K dash, or you can say D dash, as the measured value, that is the sensitivity of the overall piezoelectric network, and it gets affected because of the application of amplifier and cable. So we'll continue with the same derivation in my next lecture also. I'm ending this class here. Thank you.